Alrighty, here we are working with a sphere ball that is 60 centimeters in diameter, and it has a possible error of 1 centimeter. The first question it asks is, what is the possible error of the radius? Well, if the radius is half of the diameter, and the diameter has a possible area of 1, then I just need to take 1 and divide it by 2. So that is pretty easy. It's 0.5 centimeters, and there's no work involved in that whatever, because they are absolutely directly related. One goes up, the other one goes up. Alright, one goes down, the other one goes down. Alright, so next one. It tells me the volume equation for a sphere, and it says use differentials to approximate the error of the volume of a sphere. So, I know that V is equal to 4/3 pi r cubed. I'm going to derive with respect to r. I'm just going to derive it. So dV dr, and I do need to write it like this so that I can use differentials correctly, equals, well, my power rule tells me 4 pi r squared. If I multiply by dr on both sides, then I get dV. Remember, dV kind of represents the change in volume. dr represents the change in radius. So, I take dV equal to 4 pi r squared dr. So this is where I plug some values in. Possible error of the radius is this guy right here. That becomes my dr. So that's going to go in right here. And then the radius that I'm working with in this case is half of the 60 right there. So my radius in this case is equal to 30. So I'm going to plug that in here and here, and I'm going to get my dV. When I do that, I get dV equals 4 pi times 30 squared times 0.5, which, if I plug it in my calculator, I get 1800 pi, and I should give units. We're talking about centimeters, and it's cubed. So that's the answer for part B. So I've got A and B done. I'm actually going to leave my work here, hopefully, for part B, because I'm going to use a couple of lines. I'm going to use this line, this line, and then I'm also going to use, one sec. Actually, so what I circled in green there is the only thing that I'm going to use for part C, which I am just now seeing I mislabeled in my online PDF key. So I'll label it correctly here. This is part C. Alright, so this says using differentials, explain the maximum, or find the maximum possible error of the diameter of, I think that should say estimate, the maximum possible error of the diameter of a sphere that is allowable if the percent error of the volume cannot exceed 2%. So the first thing I need to do is find the volume in this case right here when I have 60 centimeters. And then I'm going to take 2% of that. And that's going to become my dV. So my diameter is 60, which tells me that my radius is 30, which tells me that my volume, I'm using this guy right here, is 4/3 pi times 30 cubed, which plug it in your calculator, we get 36,000 pi, 36000 pi. I need to take 2% of this number because I don't want my error to exceed more than 2%. So I found the volume of this, and then I'm going to find 2% of that so that it doesn't go up or down by that much. So my 2% of 36,000 pi is 0.02 times 36000 pi, which gives me 720 pi. What that becomes is my dV. Remember, that's my error. It's my 2% of the volume. I want the volume to not change more than this amount, than 720 pi. So my change in volume becomes 720 pi. So I'm going to use this green equation right here, and my dV becomes 720 pi. And then that's equal to 4 pi r. Well, sorry, not r. I know that my radius is equal to 30. So times 30 squared, and then my dr, which it should say estimate maximum possible error of the diameter. So I can find dr, and then I can double it, just like I halved it in part A. So my dr is what I'm going to solve for. Divide by pi, divide by 4, divide by 30 squared. I get dr equals 0.2 centimeters. Now, the question asked me about the diameter. So the possible error of the diameter is twice the radius. So d equals 2 dr. Just multiply that by 2. And I get 0.4 centimeters. And that is all for this entire problem. Whole thing's done.